Hey everyone, welcome back to the channel. Today, we're digging into two things that will instantly make your TypeScript more expressive: union types and type narrowing. Grab a coffee, sit back, and let's get to it. First up, a super quick reminder of what a union is. In TypeScript, a union is just the word "or" between two or more types. For example, let's define a type called example1 that can be either a string or a number. Now, if I create a variable called test and assign it the type example1, I can set it to something like 2. TypeScript is totally fine with that. 2 is a number after all. But if I try to set test equals true, TypeScript throws an error. Why? Because true is a boolean, and our type only allows strings or numbers. One tiny declaration gives me clear boundaries and free error checking. That seems simple, so why bother? Imagine a function that looks up a user by email. When it succeeds, it returns the account object. When it fails, it returns undefined. For this example, it doesn't matter what we include in the account object. So, to actually tell TypeScript that this function may return either an account or undefined, we must use the union operator. Okay, let's mock the function response. Now, let's check what happens when we call the function. Using a union forces every caller to handle the not found path. No more silent crashes when the database is empty. Another example is to use the union to limit the data that exists in a particular property. Let's create a type called logLevel and set it to the literal strings debug or error or info or trace or warn. Next, we may define interface, simply called log. The log interface contains two properties, logLevel and message. This log interface defines shape of log function input. Now, anytime I create a log entry, the editor auto-completes those 5 words and nothing else. So let's pick the info level and write a random message. We can try to use this method once again, but this time using the wrong log level. As you can see, the build breaks before my code ever ships. Nice. Okay, unions are great, but they raise a new question. When a function's input is a union, how do we figure out which shape we're dealing with? That detective work is called type narrowing, and we have a few options for doing it. The first and simplest tool is the JavaScript operator typeof. Yes, just a JS feature. But bear with me, this example shows its limitations, and the next one will highlight TypeScript's strengths. Picture a function named printAll that sometimes receives a single username and sometimes an array of names. Inside, I ask if type of my input equals object. Remember, in JavaScript, arrays are considered objects. When that condition is true, I loop over the array and print every name. Otherwise, it's a single string, so I just log it once. Typeof is perfect for primitives, string, number, boolean, begint, and it even distinguishes functions. But anything more complex collapses into just object, so we need a better way of distinguishing objects. When the variants share the object label, the next tool is the inOperator. Think of a circle with a radius property and a square with a side property. My function calculateArea takes a parameter called shape that can be either one. I know that the object is a square when it has the side property, so I can check if side in shape using the inOperator. Pretty straightforward. Now I can calculate the area for a square. Alternatively, I could use the inOperator to check for the radius property to determine if the shape is a circle. But what if the two shapes don't have a convenient, unique property? I mean, to clearly identify a type, I might need to check 2 or more properties. The inOperator could quickly turn into a spaghetti code generator. That's where discriminated unions, also called tagged unions, shine. Suppose I'm building a mobile game with 2 characters, a dog and a duck. Each character moves differently. Based on that, I give each character a field called kind. For the dog, kind equals the string dog. For the duck, kind equals duck. Now I'm adding a function called move that will move either of these 2 characters In my move function, I simply use a switch statement on the kind property. So, when kind equals dog, the character can run, and when kind is duck, the character can swim. A cool, easy way to differentiate types. Let's pull the threads together before we wrap up. A union type says this value can be one of several types. Type narrowing is the set of techniques, typeof, the in operator, and discriminated tags that let us pinpoint which variant we've actually been handed. Use unions to model real-world possibilities. Use narrowing to write precise bug-free logic, and you'll feel the compiler having your back with every keystroke. Give these ideas a spin in your own project and watch how many edge case bugs just evaporate. In the next video, we'll head into the wild west of generics, so stay tuned. See you next time.